What's up, guys? And welcome to day three, where we're going to look at something called a time value of money. So, to kind of introduce this idea, imagine that you have a brilliant idea for a new app and you want to hire a developer to build it, but you need to decide on a payment structure. You can either, one, pay the developer a lump sum right away. So, for instance, you pay $10,000 right when the project starts, or you can take smaller payments over time and an installment such as like $2,500 every 4 months. So the idea of the time value of money is that it means that money has the potential to earn interest over time. Therefore, a dollar you have today is more valuable than a dollar you will receive in the future because of its ability to grow. So, if you choose to pay the developer up front, you lose the opportunity to invest that $10,000 that money that can grow over time. However, you also have the certainty of having secured the developer services quickly. If, on the other hand, if you chose a series of smaller payments, you keep that initial amount of money longer, allowing you to invest it and then potentially earn interest. However, you might have to wait longer and have the developer compensated. So um, you can think of it that way, or you can say, okay, because that way kind of made it look like the second smaller option was a better choice. Another option would be you to invest that $10,000 and let that grow for a year. So if you took that $10,000 and invested it in at 5% interest, in about a year you would have 10,500, and you would actually make money on your app from paying the developer and then getting $500 in interest. And in this scenario, if you choose smaller payments, you miss out on that ability to invest the full amount right away. So these are kind of almost like four different scenarios. Like I should have specified that. So scenario one, the top one, if you choose to, so you paid the 10,000 up front, you miss the opportunity to invest it. And the second one would be better because if you paid $2,500, then you can invest the rest and let that grow. Or you can not pay $10,000 up front and you can invest that initially and let that grow, which would be the better option. And if you did that and decide to invest it, then investing the full amount rather than partial amounts would be the better alternative. So we're going to look at the calculator's time value of money solver, and it's called TVM for short. So the way you access that is you hit the apps button at the top of your TI-84, then you hit enter twice, and it will pull up, and then you actually have to hit, oh yeah, you hit enter twice. And then it will pull up a menu with a bunch of different variables, which we're going to kind of go through what they mean. So the first one at the top of the list is N, and that's the number of periods. So it is important to, as you're going through, to try to figure out, for one, is the problem talking about investing money into something, or is it talking about paying off a debt type of thing? Those two things are crucial when we know what we're going to be entering. The other thing is, are we contributing monthly to a debt or to an investment, or are we not? So, considering the big letter N that represents the number of periods, this is the total number of time periods over which you're going to make contributions or have interest applied when borrowing or investing. So if we are contributing monthly, whether it's paying a debt or investing, um, if we're not contributing monthly, whether it's paying a debt or investing, the way you're in is just the compounding period. So if it says compounded quarterly or whatever for 5 years, then you would do the amount compounded per year, 4 times the amount of years, 5, and your in would be 5. However, if you are making monthly contributions, it's your payments per year. And if I say monthly contributions, you're doing 12. There's 12 months in a year, so it would be 12 times however many years there are. So we need to consider that as we're working through some of these problems. The next one is I%. It's our interest rate, but unlike the compound interest problems where you had to convert to decimals, you're going to leave this as an interest rate. So if it's 5.5%, you're going to write 5.5, not 0.05, or not 0.055. PV is like our present value of our compound interest formula that we know. It's the initial amount that you start with, the amount you borrow or invest today before interest is added. Now, here's what you have to know concerning whether or not you're paying off a debt or you're investing. If you are investing, that means your present value. You start and you open up an account, you're actually putting money into that account. So that money is coming out and going in. So if you are investing something, that PV, that present value, is going to be negative when you invest. If you're borrowing, that present value is going to be positive, and then you start to pay that amount off. Let's see. Okay. PMT is your monthly payment. So the regular monthly payment that you make when you invest or repay a loan or debt. This amount is for everything that we do is going to be negative, because just like the PV, if you're investing something and you're putting money into an account, or you're paying off a debt, or you're doing something like that with a lump sum, or whatever, if you're paying monthly on something, you're paying that thing. Anytime you're paying something out of pocket to do something, whether it's paying off a debt or investing, that's going to be negative with the TVM solver. So the capability of the TVM solver is great. With compound interest, we can solve for present value and future value and time, and we can solve for the compounding periods and rate. We can do all that here and with the TVM solver, and it's a little easier to solve for things like a monthly payment as well, because that I don't even know that. Anyways, it's a little easier to solve for things with this without using things like logarithms when we're solving for time, for instance. So anyways, we'll go through each one of those things as we continue. The FV is our future value, so that's kind of like our A for the compound interest formula, the amount of money you will have in the future after interest is applied to your initial investment, or the amount you will owe for a debt after a specific period, which includes interest. The thing about the future value that we have to consider, once again, is this an investment or a debt? If you invest something, then in the future, you would expect that money to grow. So that future value should be more, and it would be positive, because you're making that money. You're not spending that money. You're making money off of the interest. But if you're paying off a debt, think about as you're making payments to get this debt paid off. The more payments you make, the closer you get to the end of your term, that what you owe is less and less. So in the future, right, as time moves on, the amount you owe is less and less. And as you get to the end of your payment, like you paid your last car payment or your last house payment, or your last credit card payment, then the value that it's kind of like think about it at the value you owe. That future value is going to be zero. So depending on the problem we're working on, we need to consider if we're settling a debt, if we're paying a debt, if we're investing, things like that. That this P slash Y, that stands for payments per year. If we are not contributing monthly, then this number is going to match what our next thing that we're going to talk about is. And if we are contributing monthly, then this is just going to be 12. Like it's going to be, if not contributing monthly, it's going to be the same. Or the amount of compounding periods in a year, which is 12. If not contributing monthly, it's going to be the same as CY, or which is the amount of compoundings per year. But if we're contributing monthly, your PY is going to be 12, because if I'm contributing monthly, I'm paying something 12 times a year. So that's how many payments I'm making per year. And then CY is just how many compoundings I have for a year. This end and beginning indicates the cash flow, which occurs for each period at the beginning or end of the month. We're always going to use end for this class. And it's by default should already be selected. So let's look at an example real quick and see if we can fill in all of these things. We're told that you deposit $1,000 into an account earning 3% interest per year. What is the balance at the end of 2 years? So the first thing I'm going to do is figure out, I'm just going to kind of go in order and look at my end. This says nothing about contributing monthly. So my end value is the amount of compounding periods then, which if it's compounded annually means 1, like 1 year. So that would be 1 times the amount of years, which is 2 years. So my end here is just going to be 2. My I% is going to look at my interest rate, which is 3%, and I'm just going to write 3. I'm not writing this as a decimal with the TVM solver. My present value, I'm depositing $1,000. So I'm taking out $1,000 of my pocket and I'm putting it into a savings account. So because I'm investing here, it's going to be negative 1,000. My PMT stands for monthly payment. Since I'm not doing anything monthly, there's nothing in this problem that says that. That's going to be 0. And my future value is what I'm trying to find. So I'm going to come back to that here in a second. Since I'm not contributing monthly, my PY is going to match whatever my CY is. So my CY is how many times I'm compounding in a year. If I'm compounding annually, they're both going to be 1. And then I'm going to select N. Now we're going to go through and solve for PMT, for PV. We're even going to solve for N. And the way we do that is we fill in everything, and then we go back up and highlight that FV, and then we hit this alpha enter. And then what should pop up on that screen should be this. I rounded that, but $1,060.90. And so if I invest $1,000 today in an account that earns 3% interest, in 2 years I would have made $60.90 in this account, because the difference between what I put in and what I have in the future is that's the interest associated with that. Okay, let's do the same thing with quarterly. Well, if I'm doing it quarterly, nothing here has changed, which is why I still have the things up here, except the thing involving like what I'm compounding by. So if I'm compounding quarterly 4 times a year, I'm not investing monthly, so 4 times a year for 2 years, that N would be 8. My future value is what I'm trying to find. My PY and CY are going to be the same because I'm not contributing monthly, and they both have to do with compounding, how many times I'm compounding a year, which would be 4. And then I go back up and hit alpha enter, and I get $1,061.60. What we should notice is that every time our compoundings get more and more, our interest is compounded more frequently. The amount that we get in return from this investment should be more and more. Not a whole lot, but in this case, but it should be more and more. Similarly, if we're paying off a debt the same way, like you want a debt that is compounded less frequently for your favor, because if you're doing it more, then it's more money that you're paying for that. Compounded monthly. So we're not paying monthly. Our interest is compounding monthly. So 12 times 12 months in a year times 2 years would be, it's compounding 24 times total. And then my PY and CY are both going to be 12. And then alpha enter for my FV, and I should get $1,061.76. All right, let's look at weekly. There's 52 weeks in a year. If my interest is compounded 52 times in 1 year, and I'm looking at this for a total of 2 years, then it's 52 times 2, which is 104. The PY and CY, once again, I'm not contributing monthly, so this is going to just be how many times am I compounding in a year? 52, 52, hit alpha enter, and we get 1,061.82. Once again, we should notice that every one of these amounts is more and more the more times we compound in a year. Daily would be 365, so it's compounding every single day. So in 1 year, interest is compounded 365 times. If I do that for 2 years, it compounds for a total of 730 times. My PY and CY are going to be both be 365, and then alpha enter on my future value, and I get $1,061.83. So I'm going to have you guys try this. If you're watching the video, you can try to do a TI-84 on your phone if you have one, or you can use one in my class if you're watching this for the first time. When you get to school, you can search for one and try to find that, and then plug in those values. And I'm not going to go over them. I'm just going to kind of put them on the screen. But for annually, quarterly, monthly, and daily, we should get the following. For the next one, you deposit $2,000 at 4%. What's the balance at the end of 3 years if the interest is deposited annually, quarterly, monthly, and daily? So you can look at where these numbers are coming from, and then yeah, that's what we got. Okay, let's look at one where we do put something in every month. So Derek just got his first job after graduating college. He plans to save $100 per month. So he's going to take his paycheck, and $100 out of his paycheck is going to go into the savings account every payday, the last day of the month. The account earns an interest rate of 3.6%, compounded quarterly. His grandmother gave him $1,000 to start the account. So what is his balance after 5 years? So my N, if I am contributing monthly, which I'm told it's $100 per month, he's putting in that he's paying monthly, so he's paying 12 times a year, and he's doing this for 5 years. So we're not looking at compounded now. We're looking at how many times is he making a payment in a year, and it's $100 per month. He's putting that into his account. So the end value is going to be 12 because he does it monthly. times the amount of years, so 60. 12 times 5 is 60. Then the I percent is going to be 3.6. Our PV, now he doesn't actually, he starts the account with money his grandmother gave him, but it's still going to be negative because it's going into the account. It doesn't necessarily mean literally out of his pocket. His grandmother gave him $1,000 to open up the account. It's an investment, so he's taking $1,000 out and then putting it into this account. The PMT is he's paying $100 out of his paycheck every month, so that's going to also be negative as well. The future value is what we're trying to find, and then the payments per year, the PY, he's doing 12 payments of $100 in 1 year, so that would be 12. And then the CY is compounded per year, so the interest is compounded quarterly, so that's going to be 4. There's 4 quarters in a year. We're going to do alpha, enter, and that should give us $7,757.64. So how much did he earn in interest? Okay, so let's think about this real quick. He only paid, so what we need to think about, like what he actually paid. So he paid that $1,000. So he put that in. He contributed $1,000, and then he paid $100 a month every month for 5 years. Okay, so let's think about that real quick. We want to figure out how much he's contributed. He put in that $1,000 from his grandma, and then he did $100 a month for 5 years. So in the end of 1 year, he had put in $1,200, and then times that by 5 gives us $6,000, plus the $1,000 that his grandmother gave him, means that him and his grandmother contributed $7,000 to this, but at the end of 5 years, there's $7,757. So the difference of that is our interest that we had. So he made $757.64 in interest alone. How much would he have in his account if he retires at the age of 70? So now here our years have changed. So we're still contributing monthly. So we need to figure out the difference between 70 and 25. So if he opened his account when he was 25, that'd be 35, 45, 55, 65. That'd be 45 years. So he's doing this for 45 years, putting $100 in a month. So in 1 month, he puts in $1,200, and then for 45 years. So our N would be 12 times that 45, which would be 540. Our interest rate is still 3.6. Our PV has not changed. Nothing has changed about the amounts. So it's still negative 1,000 from his grandma and negative 100 for the PMT for him every single month. The future value is what we're trying to find. The PY is how many times is he contributing monthly, paying monthly payments. There's 12 because there's 12 months in a year. The CY is compounded quarterly. That's going to be 4 still. And then, okay. So the only thing that really changed was the N. And then we're going to do alpha enter. $139,304.31. So let's see how interest works when we invest longer. So going back, how much did Derek earn in interest over those 45 years? Well, we started with, once again, $1,000, and then we put in $100 a month for 45 years. So for 1 year, it was $1,200 times 45 plus the 1,000 gives us 55,000. That's a pretty good. That's a pretty good investment. Making $84,000 for like not actually working. Like, I mean, you're working to put in the $100 a month, but it's like you just made $84,000 in an account that's, you can use for your retirement or whatnot. All right, so that is our introduction to the TVM solver.